All right, here we are at the Atomic Math Challenge, and you should have a paper that looks like this. Also, what will be helpful is if you have a periodic table of elements. If you're in the classroom, I have a whole bunch of them on the walls, or I actually have placemats. Remind me and I'll get those down for us to use. But probably the most handy is in your book, and it is going to be reference page 12. All right, you have a periodic table that looks like this. So I'm going to stay on here. This top number, which is a nice whole number, is your atomic number. This 1 or 2 digit part is the chemical symbol. If it is one letter, like hydrogen, it's capitalized. If it is 2 letters, like aluminum, or down here at beryllium, the first is capitalized and the second is lowercase. You'll see later on why that is important. And then that is the symbol, and then underneath it is the full name. And on the very bottom is the atomic mass. Most of the time, this is not a nice whole number. For instance, aluminum, its atomic mass is 26.98. So we're going to label those on our paper. So I'm going to come back to this paper, and we're going to label these. Do you remember what this first one is called? Nice whole number 8. You're right, that is the atomic number. So you can also write this on your paper. Now, do you remember what the atomic number equals? All right, well, if you said the number of protons or neutrons, I'm sorry, I am wrong. Protons or electrons. Ooh. Make that not so thick. There we go. All right. This O is the chemical symbol. This is the actual element. And down here, this number that is not a nice whole number is the atomic mass. Do you remember what the atomic mass equals? It's the number of protons plus the number of neutrons. Now, because we learned earlier that the number of protons is the same as the number of electrons, we could also say over here, instead of protons plus neutrons, we could say electrons plus neutrons. Now, what this information will help us do is figure out how many particles are in one of our elements. So let's do oxygen together. We just started. The atomic number, it would be that nice whole number, is 8. The atomic mass is 15.99999, but we round it to the nearest whole number. So if we look next to it, 9 means that we'll round to a nice 16. All right. Now, remember, the atomic number tells the number of protons or electrons. So if our atomic number is 8, then we have 8 protons, and we have an equal number, 8 electrons. Now, for the number of neutrons, if we know the atomic mass, right? And atomic mass is 16. 16 equals the number of protons, which is 8, plus the number of neutrons. So if we just switch around our fact families and subtract 8 from 16, we get 8. So there also must be 8 neutrons. And then if you look in our periodic element square, what's missing is its name. So we're going to write in here oxygen. Okay? So that's how I would go about thinking about this. I'm going to change colors here. And I'm going to do one more with you. Now for zinc, you might say, well, I have no idea what the atomic number for zinc is. So if we go back to our book, right, and if I look, see if I can find zinc on this side. Might have to go to the next page. And here's zinc. All right, so we're missing the symbol Zn. So I'm going to come back over here. All right, and we're missing, remember it's a capital Z and a lowercase n. All right, now the atomic number is, good, if you said 30, that's the nice whole number at the top. The atomic mass is the messier number on the bottom. Do you remember what we do? Do we keep it a decimal or do we round it? If you said rounding, you're correct. So I look over, that's a 3, so we're going to keep it at 65. So the atomic number up here at the top tells us the number of protons and neutrons. That's 30, which is equal, remember we have that up here, to the number of electrons. So we have 30 electrons, right? And then for neutrons, if we take 65 and we subtract the number of protons, 30, then that would be the number of neutrons. So you can kind of set it up here as a subtraction problem right in here. So if you take the atomic mass minus the protons right here, that will give you the neutrons. All right, so let's try the next one. We know the atomic, or not the atomic, but the element number is Li. So if I come back to my periodic table and I search for Li, I'm looking really carefully, I don't see it there, I'm going to go over here. Here it is, right up here. It's lithium. So since I'm looking up here, I'm going to make sure that I spell it correctly. All right, it's lithium. Okay, its atomic number, again, is 3. The atomic mass, we're going to round to 7. All right. The atomic number tells us the number of protons and electrons. And to find the number of neutrons, remember I have this nice subtraction set up. 7 minus 3 is 4. Okay. So the assignment asks you to go on this paper and from either the front or the back, pick any 6 that you would like to complete. And so I appreciate you watching, and good luck to you.